Hello again. Thanks for joining us. This is Space Nuts. My name is Andrew Dunkley. Coming up, we're going to look at the Death Star. Yes, we've gone from science to science fiction. No, not really. But there is a moon that looks like the Death Star from Star Wars, and it's now in the news for a very different reason, because it's not blowing up planets, but it's blowing up scientific minds. We'll also be looking at the potential for bacteria to have survived the rigours of life on Mars and what that could mean for future expeditions to the planet by humans. All coming up on this edition of Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And joining me to unravel all of that is Professor Fred Watson, astronomer at large. Hello, Fred.
Hello, Andrew. How are you doing?
I'm good. You're not so flash at the moment. Not feeling a bit under the weather.
Under the weather, yeah, from all different directions, which is, anyway, that's all right. We'll be fine. We'll be fine.
We're kindred spirits at the moment because we've both been mysteriously bitten by insects that have left an impact.
Yeah.
But yours is worse than mine. Yours sounds nasty.
It may take me to hospital today to get intravenous antibiotics, which...
Wow.
Yeah, that's big time stuff, isn't it?
Yeah.
Forget the pills I've been taking.
Yeah. A lot of people ask me about Australia and how dangerous it is because of all the snakes and the spiders and the box jellyfish and the drop bears and all those things. But it's the insects are more likely to get you.
Well, yeah. And I have to say, you get the odd mozzie bite, which can be annoying and itchy for a while. We've got actually some cream that Marnie found that you put it on. I think it's homegrown in Australia, and you immediately reek of the ashes of a wood fire, and it sends the mozzies away.
Oh, is that right?
Like wood fire ashes. They probably think, oh, the smoke there, that's a bit dangerous. Must keep going. So it does work.
That's a clever one.
It is a clever one. Yeah, it's very clever.
When I was a kid, I used to stay at my grandmother's place, and she used to always, in summer, put a mosquito coil on the floor next to the bed.
Yeah,
and to keep them away. And
that's right. Yes, we use those if we've got a dinner party outside or something like that.
So do we.
Yep.
It probably wasn't the greatest idea in the world to have this little thing smouldering away in a bedroom, but anyway.
No. Just passive smoking, that's what it is.
That's what it was.
Yeah. I mean, you mentioned the white-tailed spider, which
earlier on,
suspecting might be what's got me. And is that the one that causes
ulcers?
Necroleptic.
The flesh-eating thing.
Although flies. Yeah.
They've been studying that, and I think it's been debunked. But it might be an opportunist bacteria that follows the bite that could cause that. So maybe not the spider that causes that flesh-eating problem, but a bacteria that comes in later. But there have been cases of it in Australia, and white-tailed spiders, sadly, very common in homes.
I don't know that I've ever seen one, actually, in my 42 years of living in Australia.
Oh, gosh, I've seen gazillions of them out here.
I assume they've got a white tail.
They've got a white tip on the back of the abdomen. Yeah. And their body is sort of elongated. They're not traditionally round spiders. They're more that shape.
Long and thin.
Yeah. But you don't really want to tangle with one of those.
I can, if that's what I had, I can vouch for that.
Well, I got bitten on the arm at golf, and I never felt it, and I never knew it was there until I saw it that night, and it had all blown up. But all right. Enough of our sad stories.
The jolly stuff. Let's get on to the serious stuff.
Let's do that. Now, the Death Star is famous in Star Wars because it was a moon-sized space station designed to destroy planets. And there is a Death Star in our solar system, at least in terms of what it looks like. And it's a moon that you mentioned, Mimus or Mimus. And the reason they call it the Death Star is because it's got a collision point on it, an impact point on it that makes it look very Death Star-like. But it's in the news now for a very different reason. Fred, what's going on here?
It is, yeah. So that Death Star dent in it, which is very spectacular because it's perfectly symmetrical, is, of course, an impact crater, as you said. And unfortunately, I can't remember what it's called, but I'm sure you'll find it very quickly on the interweb. The story, though, is a surprise, and it comes from some work, I think, if I remember rightly, it's by French scientists. I can't find the reference at the moment, but we will shortly. And what they've done is something that's pretty standard in astronomy, in planetary science. They've looked at the libration or libration, depending on whether it's Mimas or Mimas. A lot of people call it libration. We were taught libration, which is the nodding from side to side of a moon around a planet, whose normal position is to face the planet. So our moon does this. Our moon is perpetually facing the Earth, but it actually librates. It nods slightly from side to side, just enough to make it, I think it means we see 60% of its surface rather than just 50%. It's a number something like that.
Okay.
But this libration, if you study it carefully, will tell you things about the internal makeup of whatever moon it is you're talking about. Because, and this is particularly the case, this is how the oceans of Titan, of Enceladus, of Europa, and of the other one,
Ganymede.
Yes, Ganymede, that's right. Oh, gosh, maybe it's brain fog. Anyway, that's what basically alerted them, because if you've got a global ocean underneath a covering of ice, which is what these worlds have, and the global ocean sits on top of a rocky ball, a rocky world, what it means is that the surface that you see is decoupled from the solid mass of the moon itself. And so the moon librates or whatever, nods from side to side, but the surface doesn't exactly match it, and it kind of follows it slightly. So
like a lag effect.
Yes, that's right. So when you look at the surface, you know what the libration should be, but you don't see it on the surface. You see something different. It's a wobble that is different from what you know the moon itself is doing, and that reveals that you've got this thing. You know, the icy surface is floating on top of a liquid ocean. It is astonishing science. I have to say, this sort of thing blows me away, Andrew. Because it needs very, very careful observations. But it was perhaps most spectacularly found with Saturn's moon Titan, because people realized when they mapped the surface of Titan with the radar on board the Cassini mission, Titan's got an opaque atmosphere, so you can't see down to the surface, at least not very clearly. When they mapped it, they could see that they measured the latitude and longitude of various features on it, but they could see that they were changing. And, you know, on Earth, your latitude and longitude don't change. They always stay the same. If you neglect continental drift, so they do change over very, very long periods of time. But on Titan, they change on I can't remember what the orbital period of Titan is. I think it's around a month. I can't remember. Anyway, somebody will tell us. So that's what betrays. It's a smoking gun for an ocean. And sure enough, that has been discovered on Mimas. Now, it turns out that the measurements that were made of Mimas's rotation, basically when the teams did the analysis, what they discovered was that there were two possible causes for this phenomenon. And one of them was a rocky core, no ocean. One solution was no ocean, but a rocky core that is elongated rather than being perfectly spherical, an elongated rocky core. I should mention, well, before I forget, Dr. Valérie Laini of Observatoire de Paris, place which is always worth a visit. They have done this work. He's led the team that's done the work. So they had to sort out whether this thing was due to an elongated core or due to an ocean. And what they did was looked at other irregularities in the orbit. I've got the wrong page open at the moment because there's quite a lot on the web about this. Let me just.
I did some research on that impact point. I think it's called Herschel.
It is. It's Herschel. Yep. That's correct.
Okay.
Yeah. So I'm just trying to. It would be nice to be able to show why they could eliminate
the rocky core theory.
Yeah. So they did more work on the rocky core theory, and it turned out that the only way that it could fit the observations was if it was, yes, elongated, but also flat like a pancake. And things don't appear like that. Mimas is very spherical. For it to have a pancake-shaped core in the middle is extremely unlikely. And so they're pretty keen that, yes, they've discovered the ocean on Mimas, which is absolutely fantastic news because Mimas is pretty small. Enceladus is 500 kilometers. Mimas is nearly 400. So it's not that much smaller than Enceladus, which we know, of course, has a sub-ice ocean because we've seen the geysers that come through the ice with Cassini. Cassini's actually flown through them, so we know what they're made of as well. Now, the remaining puzzle to this story, Andrew, because we always cover the remaining puzzle on Space Nuts, is Enceladus and Mimas, apart from one being slightly bigger than the other, are totally different in their surface structure because, as we've already mentioned, Mimas has lots and lots of craters, not just Herschel. Herschel's the biggest one by far. It's got lots and lots of craters. And that speaks of an ancient surface. So, unlike Enceladus, which is almost perfectly smooth, it's got cracks in the surface, and that's where the geysers spew out. But it's virtually 2 or 3 craters. It's very, very uncratered. So the scientists have taken that information and looked again at details of the orbit of Mimas in relation to the other moons of Saturn. And they've evolved a theory that includes the interaction of these bodies gravitationally with one another. And what they think they've discovered is that the various orbital resonances, if I can put it that way, things where one planet goes round in the same time twice as the other goes round 3 times, that sort of thing, these are what we call resonances. Those resonances may well have a history that tells you that something happened maybe only a few million years ago to change the dynamics of Mimas. I can't remember what the number was that they said. It's a matter of a few million years that this ocean must have been there. And so it's a recent phenomenon and probably caused by gravitational tugging by the other moons and by Saturn itself, which has heated the core of Mimas and heated it to the level that the ice that's in contact with it has actually melted. So it's really, really clever stuff. And that also neatly explains why we've got this ancient cratered surface, because it hasn't started spewing out geysers of material yet. It's still a young ocean, And I think that's a very exciting discovery. I'm sorry, I can't locate the age that they think the ocean is, but it is just a few million years, maybe less than 2 million years. It's a very, very recent one, geologically, of course.
Yeah. I suppose if it's only a recent ocean development, that reduces the chances of Mimas being a candidate for life beneath the surface.
Yeah, I think that's a really good point. I think that's true. Although, we don't know how long life takes to form. I mean, by that I mean kind of rudimentary life. If the core of Mimas is heated up enough, then you'll get these black smokers that we get on the floor of our Earth's oceans. And we think from evidence that came from Cassini that they are present on Enceladus. They could have kicked in pretty soon after the melting. So maybe we've had, the chemical ingredients for life and enough heat input caused gravitationally by gravitational heating that we might have life sparking off there as well.
It's interesting because now we're finding, this is another ocean moon, and it looks like Jupiter and Saturn do share this quality. And there's a whole bunch of them now. There's all sorts of possibilities, and it's going to be very tempting for scientists to send more and more missions out there to see if they can find life. I know Europa Clipper's heading out pretty soon, but I doubt that that'll be the last one.
And Juice is on its way.
Oh, yes, isn't it? That's right. It is too. Forgot about that.
Ice moon. It's thought too that it's Neptune's moon, I think, isn't it? Yes, Neptune's moon Triton may also be an ocean world. So, it's and actually even further out, it's thought that Pluto is too. And I have seen a paper that suggested that Pluto's moon Charon might be as well. So, 10 a penny, these things.
Yes.
They're everywhere, which is astounding. As you know, because we've talked about it before, on Europa, the amount of water that's underneath the surface is about twice all the water in the oceans of the Earth. It's phenomenal stuff. Such a different picture of the solar system from what we had back in the day when I first started learning about astronomy. It's incredible stuff.
Well, I remember the books we used to read at school, and they were very, it was very basic. They didn't talk about the moons of the planets so much beyond Earth because it just wasn't considered.
Yeah. There were just dots of light in the telescopes of the time, certainly in the books I read. So they talked about their orbits and things like that, but never about their morphology, the shape of them. And what changed that, of course, were the Pioneer missions. Pioneer 10 and 11 flew past Jupiter and Saturn, I think. I can't remember. And they revealed what a rich tapestry of structure we've got out there in the deep solar system. And that, of course, spawned the Voyager missions, which just really hit the nail on the head in regard to this sort of science. Fabulous.
Yes, indeed. All right. If you'd like to read up on that story, it's on the space.com website, but there are several stories about it floating around online, so you can pretty well find it anywhere through a Google search or whatever search engine you use. This is Space Nuts. Andrew Dunkley here with Professor Fred Watson. Let's take a short break from the show to tell you about our sponsor, NordVPN. And I've spoken to you many times about a virtual private network and the benefits that it gives. And I do personally use NordVPN. And yes, I did pay for it, just in case you're wondering. A few people might ask. No one has, but you might. But yes, I did pay for it. I got the 2-year plan with all the bells and whistles. So I've got everything that comes with that service, and that includes the virtual private network. My favourite part, which I've told you before, is the password protection system, which stores all your passwords and your usernames and all the information in one handy location, so you only have to remember one password. I particularly love that. One of the other tools in there, though, is the next generation file encryption. Now, this one sort of works in the background, and it does a really fabulous job. It basically generates ciphers and cryptography algorithms to keep your files, your identity data, your digital signatures safe on your device and on the cloud. The other thing I like about NordVPN is it works on everything. It works on Windows, it works on Mac, it works on Linux, it works on Android and Apple devices, it works on Windows, it works on Firefox. Basically, any browser system you've got, you can load the NordVPN system into the browser proper. And so it's always working away in the background. Of course, VPN services are fabulous for public Wi-Fi and any situation you find yourself in where there are lots and lots of people around using Wi-Fi. You just never know when somebody will be there to try and, hack your systems and take your personal data, whether they're stealing your identity or stealing your money. It could be both. But the deals that are getting done on the dark web to create fake identities using your information is just out of control at the moment. And you can protect yourself simply by getting a virtual private network, and there is no better than NordVPN. They've got a birthday offer on at the moment too, by the way. They'll give you an extra 4 months, and if you buy one of the plans on the 2-year deal, you'll get an Uber Eats voucher as well, by the look of it. So it's a pretty good deal. In fact, it's a great deal, and I certainly do endorse their product. It's the best in the business, and they guarantee high speeds from all their servers. You won't lose anything in the translation. The URL you need for this, and don't forget their 30-day money-back guarantee, is nordvpn.com/spacenuts. It's an exclusive deal for you as a Space Nuts listener. nordvpn.com/spacenuts. Once you get in there, click on Get the Deal and have a read through all the products and the plans and see what works for you. nordvpn.com/spacenuts. Now, back to the show.
3, 2, 1.
Space Nuts.
Now, Fred, let's move on to the next story, and Mars is in the news yet again. I actually, just as a sideline point, read this morning, I think, that they're going to try and do a flutter test on the Ingenuity helicopter. To what end, I don't know, because last time we spoke about it was end of mission.
Yeah.
Now they're going to try and they'll do something with it. I don't know what that will achieve.
I think it's about sort of stressing the bits to their limits and see what it can cope with. In terms of the physical structure of it, just to do tests that will reveal a bit more about how Ingenuity has coped on Mars. I mean, there's another fantastic story, isn't there?
Even in death, it continues to deliver.
Yeah, absolutely. Absolutely.
Now, but the other story that's come up about Mars is in regard to bacterial life potentially, and I think they've done some tests that prove bacteria could survive in that environment, and of course that brings up question marks about sending humans to a planet that may have bacterial life. So there's a lot of interest in this particular issue, I would imagine.
Yeah, that's right. The paper, the research paper in which this work is published is entitled Survival of Environment-Derived Opportunistic Bacterial Pathogens to Martian Conditions. Is there a concern for human missions to Mars? So the last sentence is the bit that's the important bit. So what this team has done, and there's quite a long list of authors, they're described in our good old phys.org website as an international team of radiation specialists, biologists, and infectious disease experts have found 4 types of bacteria that are capable of surviving exposure to the hostile Mars environment. This was published in Astrobiology, which is the right journal for publishing it. And so they've essentially taken 4 human infectious bacteria and basically exposed them to Mars-like conditions. And I think the only one that you can't simulate on Earth is the 1/3 gravity. You can do the radiation, pressure, temperature, all of those you can simulate. Yeah. You can't simulate the low gravity, but you would imagine that as far as bacteria are concerned, the low gravity is not really that much of a problem. It's going to probably enhance their survivability rather than reduce it. So what they've done is they've taken these bacteria, which are known to be capable of surviving in really, really difficult environments, the things we call extremophiles, they love extremes. And they've, especially ones that, that are fine with high amounts of radiation or salt, poisons. There's one lot of bacteria that live cheerfully in this toxic lake. Can't remember, I think it's South America. Extreme temperatures and almost no water. I haven't seen it on the list, but my favourite of these is, what is it called? I'm going to get it wrong, aren't I? I think it might be Dinococcus radiodurans, which can withstand 3 times the lethal dose. 3,000 times the lethal dose of gamma radiation for humans. Wow. So what would wipe out a human, they can survive 3,000 times.
We see it all the time in medicine because bacteria can build resistance against antibiotics. So, and that's a poison. That's a poison to them. Yeah. And we're reaching a point where we've got to come up with new ways of dealing with bacteria because some of the antibiotics have been rendered practically useless. So it's a similar situation, I suppose. You're touching what concerns me today with that infected insect. Yes, sorry.
Because, no, that's all right. It's just such a classic example of survivable bacteria because the antibiotics that I've taken so far don't seem to have had any effect whatsoever. So I'm going to have to go to Mars, I think, Andrew, to get rid of this spider bite.
Or you might pick up something else. That's it. That's the problem.
Yeah, that's right. That's what this story's about, of course. I can't pronounce the names of the bacteria because I'm not a biologist, but radiodurans is not one of them. I actually, I'm going to cheat here. I drew a cartoon about that in Space War.
Oh, did you?
Yeah, just...
All right. Yeah, why not?
I better where are your cartoons when you need them?
Oh, of course. But usually in the middle of the Sunday papers.
Well, they are normally, but I tended to put some in a book. Should be.
I bet you drew them yourself too, Fred.
I did draw these myself, yes, because I enjoy drawing. Well, I do when I get the time. I never seem to get the time these days. Where is it? Come on. You're around here somewhere, I know, because I wrote the damn book. Here we are, 228. So it's a conversation, and it's at microbe school, and I've drawn the microbes as they appear in electron microscope images.
Yeah,
and the little one says, "Hi, I'm Streptococcus mitis. Who are you?" And he says, "Yeah, I was right. Dinococcus radiodurans." So Streptococcus says, "What do you do?" And radiodurans says, "I live inside a nuclear reactor. I love a bath of acid or being in space. I can survive thousands of times the lethal dose of radiation for humans. What about you?" "Oh, I don't mind hot tea. And I once lived on the moon." Whoa! Because that's the bacteria that they found on the Apollo 12 mission. Streptococcus mitis. They're the only two I know because they are probably extremophiles of the classic kind. Anyway, I've rambled on enough about this. The bottom line is these 4 bacteria actually survived all the tests that they did. 3 survived for 21 days, and 1 seeming to multiply and thrive.
Wow.
And so the conclusion of the team is that bacteria carried inadvertently to Mars could pose a health risk to astronauts, particularly if the bacteria mutated to help them better survive the harsh conditions. That's a direct quote from phys.org.
Which they tend to do. Viruses do it. Bacteria does it. There are even some creatures that can survive in space, which we've spoken about before, which are the tardigrades.
Tardigrades, yes, that's right.
Yeah. So, and I suppose that really underlines what life is all about. It's about surviving, finding ways to survive.
Darwinian evolution. That's what it is.
Yeah, adapt and overcome. So, that's a really interesting problem that they're going to have to deal with. I suppose they'll have to take a lot of Glen 20 with them. To be honest, that's probably the answer.
Well, they do already, because every spacecraft that goes to Mars has to go through, what's it called? Is it stage 4 planetary protection rules? I wrote about that in here as well, but I can't be bothered. So they disinfect everything.
That writes Mars off for me, because I can't stand the smell of Glen 20 and having to suck that stuff up through my nose for 3 months. No chance. I'm done.
More like 18 months, Andrew.
Probably.
Yeah. Oh dear.
See, I was just assuming I'd be on the fast track, but anyway.
Well, yes, you probably would be, actually.
You never know. Yes, the safety of astronauts on Mars because of potential bacteria survival and then adapting to the situation could pose a risk. And if you want to read about that, it's in the phys.org. It's an article on phys.org, which is a fabulous website if you want to read all these space science stories. They're just they do a fantastic job. That wraps it up, Fred. Just a reminder too, if you want to listen to Space Nuts Q&A, that will be coming up on Monday. It'll get downloaded to your respective platforms automatically if you're subscribed to us. And if you're a follower on YouTube, don't forget to hit the subscribe button below. Thanks, Fred. We will catch up with you real soon. Fred Watson, astronomer at large, and he joins us every week on Space Nuts. And I hope you'll join us again very, very soon. We'll catch you then. From me, Andrew Dunkley, bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com. This has been another quality podcast production from Bytes.com.